Vamos a seguir con un par de ponencias relativamente cortas en las que vamos a cambiar el enfoque, pero vamos a seguir muy conectados con la idea de alargar la vida útil de las estructuras. Especialmente en la primera nos va a acompañar nuestro compañero Moritz Streicher, es ingeniero especializado en soluciones de refuerzo estructural dentro del grupo Fischer, especialmente en lo que respecta a las fibras de carbono, al uso de fibras de carbono, y nos presentará diferentes técnicas aplicadas a estructuras reales también. Moritz, por favor.
Well, first of all, thanks for the introduction, and I wanted to thank the whole team from Fischer Spain for the impeccable organization of the event, and every one of you for the interest and the presence today. I'm from a department one step further down the line compared to Martin Neumann, who gave the excellent presentation on monitoring of structures, namely from structural retrofitting. And my presentation will be on extending the lifespan of structures, of which we heard already from Professor Bergmeister and some other speakers. And to give you some insight, some further insight on why it's important, especially for the next 2 decades in Europe and the United States, I have a few data from Germany with me today. Let's see. Sorry, wrong direction. So on the upper right side, you can see construction of highway bridge infrastructure in Germany. And as you can see, most of the infrastructure has been built after the Second World War with the economic rise and also with the Marshall Plan, of course, fostering it. And most of it is built in the 1970s, meaning it's more than 50 years old at the moment. And the topic of maintenance has become very hot in the last few years, but for decades it hasn't been. So actually, much of this infrastructure is deficient at the moment. And in the small inlay, you can see the increase in traffic loads from the 90s to today, which is at least 70%, not even talking about the increase from 1970 to today. So all those bridges back then were not designed for the traffic loads today and are currently aging. On the other hand, in the lower graph, you can see the investments, the European investments into infrastructure, and the orange bars over here are on road infrastructure. So it's actually stagnating investments into infrastructure, and if you correct that for inflation, it's actually a decrease. Therefore, we are facing challenges in construction, which already have been mentioned to a certain extent. We have aging infrastructure, we have insufficient investments, and increasing labor and material cost in construction. And at Fischer, we always try, as Dr. Mihala already mentioned in his talk, we already try to orient ourselves at customer needs, and of course customer needs in the construction industry are aligned with the general challenges of the construction industry, which is why we require construction materials which are for higher durability and service life. For example, anchors that are certified for 100 or 125 years mean a significant cost reduction for customers if you don't have to exchange fixings at a certain point in time in the construction. Also, we have to reduce construction times, which is associated directly with Emil Kral's topic, the Bobot, in tunnel construction, for example. But on the other hand, also, we have to deliver solutions for modular construction and industrialized construction in order to become faster and also more cost efficient. But the block that I'm focusing on is on effective maintenance on structures, because as Professor Bergmeister pointed out, we have pretty nice infrastructure at the moment and we need to maintain it. It's the most cost-effective way, and the easiest way there is predictive and preventive maintenance to prevent it from actually becoming insufficient at any point in time. But which is also why, for example, connected products has become an interesting and important topic for Fischer. But once maintenance has failed, we need a toolbox to actually be able to retrofit our structures, which is why our department actually, or where it comes into play. And if you think about the lifetime of a structure, mostly, of course, it always starts with the construction phase. You have a use phase during which you should do the maintenance. Often the maintenance is not properly done. You have a need for retrofitting and over time for modernization. And nowadays, we have still much too much demolishing and new construction around the world, which goes along with higher cost compared to more cost-effective solutions of proper maintenance, even though it's a running cost. That's why many people try to avoid it, because you can actually try to shift the cost for 30 years, 40 years. But in the end, it comes in more expensive. And if we can simply cut that cycle a bit shorter and increase the lifespan of structures due to modernization and proper maintenance for a few more cycles, we actually win a lot. There's many different reasons for retrofitting. It may not only be deterioration. We have structures that are being repurposed. For example, in Dubai, they have hospitals now becoming hotels, or parking garages becoming residential buildings. We have increasing traffic load, so you may be in the need of strengthening bridges for higher traffic loads, or also for seismic loads. You may need to, we heard about the issue with corrosion. It is very also in sea-near regions very present. You may need to contribute for a loss of reinforcement cross-section with additional reinforcement at a later point in time. You may have compliance issue with new changes in code, for example, restrictions in fire. Or you may have additional loads on your structure, such as heavy machinery or rooftop solar power plants, which may not have been originally accounted to in the design of the building. And I have one example, which yesterday at least we found, which is rather nice, maybe the most well-renowned retrofit in Barcelona, the Casa Batlló, which was 1 story shorter before and got a nice new roof and facade by Anthony Gaudí. And at Fischer, we already have a portfolio for retrofitting, and I'm focusing on strengthening today, even though retrofitting covers a way larger area of than just strengthening products. And I'm not even mentioning products like wooden screws that we have for shear strengthening of beams or addition of new cross-sections in wooden construction. But since my department mostly focuses on reinforced steel and masonry construction, Fischer already has a strong portfolio in post-installed rebar solutions, as well as for shear connectors for concrete overlays that we can use with either chemical shear connectors or concrete screws, as well as bridge cap anchors, which are sold in Austria, for example, very well. And we were thinking about how to extend the portfolio to meet the market requirements as effective as possible, which is, for example, low closure times. If you want a parking garage to be retrofitted, most often they do it in 48 hours. They want to reopen in 48 hours. If you do it with concrete, you have to wait 28 days until your concrete is cured. So it needed to be fast, so we went with epoxies. It needs to be durable. We wanted to not increase the dead load of existing structures. We didn't want to decrease the free height of structures, because otherwise, if you do it with post-installed rebar solutions, you increase the cross-section of columns, you actually lose space, which is not necessarily what we want in especially crowded areas and cities. Which is why we came up with a portfolio of CFRP strengthening products. First of all, carbon fiber fabrics, which are really versatile, but a little bit more labor intense. Secondly, externally bonded CFRP laminates and near surface mounted laminates. Of course, they're very different in application and also different in their properties. For example, near surface mounted laminates have rather thin cross sections or rather small cross sections, and they are inserted in slots, drilled and milled in the concrete member. So they're not actually that good for increasing the momentum of inertia of a member, but they're really good for seismic strengthening, for example. And actually, at the moment, we're now able to cover already a pretty good scope of strengthening applications, especially in China. We also have a portfolio. It's mostly sold there. It's theoretically available worldwide for externally bonded steel plates that they use for shear strengthening of beams, but also flexural strengthening of beams, and jacketing of columns, which has to be, again, protected against corrosion, which is why we also developed corrosion protection primers and coatings. And then, of course, we have the whole traditional Fischer product series that you know, concrete screws, shear connectors, anchoring solutions, which are suitable for post-installed rebars, and now the carbon fiber portfolio. Of course, this is not comprehensive if you look at carbon fiber fabrics, of course, they cannot only be used for wrapping columns to increase the actual capacity, but also they can be used to wrap columns for increasing shear capacity or flexural capacity of columns, if that's the deficiency that you're having. And also, what is not mentioned here is, for example, shear strengthening of diaphragms and walls that you can do with externally bonded CFRP. So when we developed the products, we had a strong emphasis, because you may know that there's already competitors out there. There's MAPE, there's Sika, there's companies on the market. So carbon fiber-based strengthening products are not entirely new to the world. But as for all products that we develop, we took a great emphasis on the customer benefits, also especially for contractors. So we developed one epoxy resin which can be used for both near surface mounted and externally bonded CFRP laminates. It comes either in buckets if you want to do externally mounted application, or in cartridges for near surface mounted. So actually it comes with a specifically developed adapter, so you can use the normal Fischer mixing nozzles to simply inject the epoxy resin into the groove and save time, be fast in the construction, and have a clean and tidy construction site without any pre-mixing of epoxy resins, filling it into tube bags and then injecting it into cracks, which is a mess. And also for the carbon fiber fabrics, we were able to make it with a single resin that can be used for priming the concrete, as well as for impregnating the carbon fiber fabric in the end, which is actually pretty nice. What's not shown here is that we also have an ultra-high strength epoxy-based repair mortar with around 150 megapascal compressive strength. So it's an R4 repair mortar that can be well used for retrofitting projects, because in many applications you don't just have a structure that is deficient in terms of lacking reinforcements, but also you will have concrete spellings or something else that you may repair. You may need to reprofile a cross-section, and if you do that with a normal cementitious repair mortar, of course you're cheaper, but you'll have to wait 28 days until you can load the structure. If you want to do it in 2 days, you use an epoxy mortar and you're very fast. And since, as I said, we took emphasis into customer benefits, we also developed a series of application aids, such as a laminate coiler to uncoil the large 150 or 100 meter CFRP coils to cut it to length rather easily. And mortar application tools in order to be able to ensure that you have the same amount of resin and the same profile of resin on the CFRP laminates at all time to keep the construction site tidy and, again, to be quick. When we look at fabrics, we have some more applications than just flexural strengthening, which was mentioned on the last slide. But you can also have shear strengthening, as I mentioned before. Here we have another product involved, which is coming at the moment. It's like called a spike anchor, basically a single cured, single uncured end anchor. There's also completely uncured anchors, which are again a mess in installation. They can be used to end anchor the fabric. Basically the idea is that you bond the pre-cured part into a drill hole with our FISI Plus epoxy mortar, for example, and with the open end you can laminate on the fabric in order to prevent debonding, which gives you a larger scope of applications. You can have concave shapes that you can retrofit with the fabrics with this technology, and also you can have end anchorage of fabrics in shear strengthening, because I think Professor Bergmeister said you have to close the load loop. He was referring to another bridge structure, but actually that's what he meant, and it's one suitable solution which is also more convenient in application than most products on the market. And what's funny here, because we were in the Godot building yesterday, corners for shear strengthening or column wrapping always have to be rounded. So in a Godot building, you wouldn't have to round corners because there's no 90 degrees angles anyways. Yeah, and you can use the same product also for column wrapping, as I mentioned before. Just to sum up one more point, we've been talking about digitalization a lot, and we have the beautiful Fixperience products from Fischer, It's a whole series also for anchor channels, etc. Those modules, as far as I know, that work rather conveniently and make planners' lives rather easy, because they give you the full-scale calculation of your anchored solutions. And there's also a plugin which is called Reinforce Fix for our solutions, where you can actually dimension different beams and slabs and other members according to the most common guidelines on the market, and get full-scale printouts in order to have easier calculation methods at hand in order to do the structural design. And also we have engineers at Fischer that can aid you in case you have a project that requires more engineering judgment, because some single cases are rather difficult. I just want to sum up with one point that I didn't know if I wanted to show it or not, but since I'm between Günter Hirt and Martin Neumann, I found it funny, because we are always talking about our fields, but actually at Fischer sometimes we join expertise from different departments. And we had one research project where Fisco, Connected Products, and we collaborated on a project that faced another demand that was talked about a lot. That's publications on structural health monitoring of bridges. And you can see that in the 2000s years, it has been risen a lot. So there's an academic and also an industrial interest, as we heard today. And we simply, with Günter's engineers and some help from Connected Products, there was a sensor-integrated laminate developed. It's still only a very early research state, which can give you temperature and strain measurements over a longer length of beams and slabs. And it's actually something just nice to show that we don't only develop products on ourselves, but also we're rather well interconnected. And here you can see data on quasi-static measurements with five sensors included in a laminate on a full-scale reinforced concrete beam in 3-point bending. We've also been doing up to 10,000 load cycles on different load levels, up to 75% of the fracture load of the beam, which was way above the normal fracture load of the unstrengthened beam. Yeah, just to give you an idea of what we're doing, and I hope you liked it, and I hope you enjoy the rest of the day. Thanks for your patience.
Thank you. Thanks, Moritz. Bueno, al final, por mostrarnos lo que se puede hacer con el refuerzo estructural, ¿no? Alargar la vida útil de nuestras infraestructuras. ¿Qué hay más sostenible que un edificio que íbamos a tirar al suelo o una infraestructura pueda durar 100 años más? Y, bueno, adaptarlo a los nuevos retos.